All right, starting off chapter 2. Before I get started, just know that you're not going to be hearing as much of this anymore. Okay? Nobody told me how much tapping noises I was making in my lectures before, and I didn't realize it until recently listening to one of my lectures. So I got a different pen, and now I could write like this. Oop. Without making much noise or any noise at all. I could have done this much sooner, but nobody said anything to me. All right? So if there's ever an issue, guys, if you think I could prove anything, just let me know. Alrighty, so let's get started with the lesson. We're talking about quadratics. So here we have the quadratic function that I just wrote, ax squared plus bx plus c. The axis of symmetry formula, which essentially splits the parabola in half, is negative b over 2a. All right, and the standard form of a quadratic function is a times x minus h squared plus k. All right, and once again, y is the same thing as f of x. F of x just means that the equation passes the vertical line test. All right, the vertex is your h and k, or, this is very important to be aware of, you can obtain the vertex by using the axis of symmetry formula, because that's your x value. So negative b over 2a, that passes through the vertex. All right, and if you wanted the y value, then you're just plugging the x value into the function. That's all there is to that. All right, then axis of symmetry passes through the vertex. Okay. If a is greater than 0, if a is greater than 0, then there is a minimum. If a is less than 0, then there is a maximum. Okay, so here's an example of what we'll be working with. All right, here you have a parabola. All right, and then there's the axis of symmetry. All right, it's this line that passes through the vertex. So that's your vertex. Okay, that's your hk, or negative b over 2a, and f of negative b over 2a. This is your maximum in this case, since the parabola is upside down. All right, then we have our zeros here. These are the zeros, also known as the x-intercepts, also known as the roots, also known as the solutions. All right, all different ways of expressing the same thing. All right, and then we have the axis of symmetry here once again. And the formula for that is negative b over 2a. All right, I'll say a of s for axis of symmetry. All right, so let's apply this knowledge now in the next example. To the first page, here is standard form. Okay, so we have to rewrite our function in standard. All right, sketch the graph of the quadratic function without using a graphing utility. Identify the vertex, axis symmetry, and x-intercepts. All right, here's our function. First thing I'm going to do is put this function in descending order based on the exponents. All right, so there's that. Now I'm going to identify my a, b, and c values. A is negative 1. B is 0, since there's no x there, and C is 9. Okay, so axis of symmetry, what is it? Well, x is equal to negative b over 2a, and b in this case is 0. So I don't even really have to do much math. I'm taking 0 and I'm dividing it by some number, which is 0. Okay. And then the axis of symmetry passes through the vertex. So this x value here, you could just put right here. All right. And then to figure out the y value, we simply plug the x value into the function. So we get y is equal to, or h of x is equal to, negative 0 squared plus 9, y is equal to 9. Okay, and then the x-intercepts. Now, how do you find an intercept? You set the opposite variable equal to 0, all right, and you plug it into the function. So h of x, or y, is equal to 0, and that's equal to negative x squared plus 9. All right, so let's solve for x. Subtract 9. Negative 9 equals negative x squared. Divide by negative 1. And I get, all right, square root both sides. Don't forget the positive and the negative. All right, so I have positive 3, and then I have negative 3. All right, and then the y values are 0. All right, those are my x-intercepts. All right, now I'm going to graph it using this information. So I have negative 3, 0. And I have 3, 0. All right, and then I'm going to go up 9. I'm up here. All right, and then there is my parabola, just a rough sketch using the intercepts on the vertex. All right, going on to example 2. All right, use a graphing utility to graph the quadratic, identify the vertex, axis symmetry, then check the results algebraically by writing the quadratic function in standard form. Okay, so same deal as before. First thing I'm going to do is distribute the negative. So I have negative x squared minus x plus 30. Okay. And then, all right, so I have A is negative 1, B is negative 1, and C is 30. Okay, so using the axis of symmetry formula, all right, I can figure out what the axis of symmetry is. So I have negative 1 over 2 times A. All right, so I'm going to end up with negative a half. Yep. All right, so axis of symmetry is negative 1/2. All right. That's the same as my x value for my vertex. All right, then you could plug a negative half into the function and figure out your y value, and you're going to get 30.25 or 30 1/4. Okay, and then the x-intercepts, how do you figure those out? Okay, well, I could simply go to the original function that they gave me. And to figure out the x-intercepts, you set what equal to 0? You set y equal to 0. So I'm going to have 0 equals negative minus 30. Okay? And I'm going to divide by negative 1 here. And then this is going to become a very easy quadratic to factor. And this goes back to chapter 0. Okay, so setting them both equal to 0, x is equal to negative 6, and x is equal to 5. So for my intercepts, I have negative 6, 0, and 5, 0. Okay, and then it says, then check your results algebraically by writing the quadratic function in standard form. Okay, standard form, if we go back. All right, how are we going to do that? Let's see here. Well, let me first start off with the negative x squared minus x plus 30 right here. All right, first thing you have to do is group the first two terms. Let me pull out the negative. I need to get my a value here to be 1. Okay, so I pull out the negative. Okay, and now this is a very simple process, but it's an important idea you need to remember. If you don't remember, it can make things difficult. This is my b value. All right, I simply need to take my b value, divide it by 2, and then square it. All right, so what do I have in this case? I have 1 for my b value. I divide by 2, and I square it, and I get 1/4. So that's what I add here. All right, on the inside. Okay, but you can't just randomly add something to an expression without changing the quantity. All right, so in order to maintain the equality of the expressions, I need to also subtract 1/4. All right, but now we also have this value out here, this a value, or value that we factored out, which is negative. All right, so I have to multiply the negative 1/4 by that as well. Okay, because if you did not do that, if I simplified all this, added everything up, it would not take me back to what I previously had. It would be a different expression, all right? So in order to maintain the equality of the expressions, whatever you add inside, you have to subtract on the outside. All right, so now, almost done with this here. I have the negative on the outside here. And I could take this perfect square trinomial and convert it to a square. That was the whole idea of dividing by 2 and then squaring b. Okay, that allowed me to obtain a perfect square trinomial. So I take x, and this value here is simply this here before we squared it. So it's going to be a half. We're just adding that on. All right, and then we have plus, it's going to be 30 plus 1/4, so 30 1/4, or 30.25. All right, so that's my function now. All right, if we look above here, we could verify our results. All right, here's my h. Take the opposite of that. It's negative a half. And here's my k, 30 1/4, or 30.25. All right, so I verified it algebraically by converting the function into standard form. All right, going on to the next example. All right, if you have any trouble with this concept here, make sure to ask. This is the area that students often struggle with. But if you ask for help, that makes a big difference. Going on to the next example. Write the standard form of the equation of the parabola that has the indicated vertex and whose graph passes through the given point. Okay, so this is my h and k. This is just a point, so this is my x and y. So this is the standard form of a quadratic equation. All right, so let's just plug in the information that they give me, and I can figure out what my a value needs to be. So I have 2 is equal to a times x, which is 0, minus h, which is 2, squared plus k, which is 3. All right, so I have 2 is equal to a times 4 plus 3. All right, I'll subtract 3 here. Then I'll divide by 4. A is equal to negative 1/4. Okay, so setting my standard form equation up, I plug in my a value. This times x minus h. H is 2 squared plus k, which is 3. And there you have it. That's all there is to it. It's in standard form now. All right, begin your assignment at the bottom of the webpage. Make sure to ask questions if you have any. All right, don't wait till the very end of the chapter. Ask now.